Hi everyone, and welcome to the class video on density. Density is essentially a measure of the amount of mass an object has per unit of volume. For example, water has a density of 1 gram per milliliter. So for every milliliter of water, it weighs 1 gram. Objects that are more dense than water, like aluminum and lead, will sink in water. Objects that are less dense, like cork and ice, will float. So density compares the mass of an object to its volume. It is the mass of the substance divided by its volume. So we use the equation density equals mass divided by volume. Mass is always measured in grams and volume in milliliters, or mass measured in grams and volume measured in cubic centimeters. Remember that 1 milliliter equals 1 cubic centimeter, so these are going to give you the same number for density. It's just a matter of which unit is written down. But since milliliters and centimeters cubed or cubic centimeters are interchangeable, it doesn't change very much. When we're thinking about density, I want to go through two thought exercises. First, consider two objects of equal volume but unequal mass. For example, a cube of aluminum and a cube of gold. Here they have equal volumes. They take up the same amount of space, but one weighs more. The gold has a greater mass. So the more massive object, the one that has more mass, that is heavier, is the one with the greater density, even though they have the same volume. So remember that density equals mass divided by volume, and so when the mass is increasing, the density will also increase. Now let's consider two different objects, ones of equal masses. So here we have a cube of aluminum and a cube of gold. They have equal masses. If you put them on the scale, they weigh the same, but unequal volumes. The aluminum cube is much bigger. The object with the larger volume, the aluminum, has the smaller density. Remember again that density is mass divided by volume. So if the volume is getting larger, and density is mass divided by volume, the density is going to get smaller. Now it's time for a learning check. Osmium is a very dense metal. What is its density in grams per cubic centimeter if 50 grams of osmium has a volume of 2.22 centimeters cubed? Remember that the equation for density is mass divided by volume. Pause this video while you determine the answer. So we were given the mass and the volume. We need the density. Density equals mass divided by volume. Thus, density equals 50.0 grams, the mass, divided by 2.22 cubic centimeters, the volume, and this equals this number here. Once again, your calculator will give you a number with many more decimal places than you need due to significant figures. Both 50.0 and 22.2 have 3 significant figures, so you must round your answer so that it is also only 3 significant figures, making the final answer 22.5 grams per cubic centimeter. Now we are going to learn about a method of determining an object's density. That method is called volume by displacement. A solid that is completely submerged in water displaces its own volume of water. For example, here we have a zinc object and a measured amount of liquid. The graduated cylinder tells us that this liquid is 35.5 milliliters. When you drop the zinc object into the graduated cylinder, it takes up a specific amount of volume. It displaces, hence the name of this method, it displaces enough of the liquid that the level in the graduated cylinder rises to 45.0 milliliters. So you can calculate the volume of the zinc object by the difference in the volume of the liquid with the zinc object and the volume of the liquid without the zinc object. So 45.0 milliliters with the zinc object minus 35.5 milliliters without the zinc object gives us 9.5 milliliters, which of course is the same as 9.5 cubic centimeters, since a milliliter and a cubic centimeter are the same amount of volume. So remember that a solid completely submerged in water displaces its own volume of water. So the amount of water or liquid displaced is equivalent to the volume of the object. So this submerged zinc object has a volume of 9.5 milliliters. You can also weigh the object on a balance to obtain the mass. So now that you have the mass and the volume, you can determine the density. So this is a common way of determining the density of an object in a laboratory setting. This is sometimes known as the Archimedes principle because of a myth regarding the ancient figure of Archimedes. He was apparently asked by a king to prove that a gold crown was made of solid gold and not gold mixed with other less precious metals. Archimedes was very stressed out about having to do this because his life was possibly at stake on being able to find this answer, and he determined that he could weigh the golden crown and also get that same amount of gold from another source and then see if they displaced the same amount of water. This would prove that the crown was pure gold because it would have the same density as the pile of gold with the same mass. So he apparently, when he figured out the answer to this problem, he ran through the streets screaming "Eureka," which means I found it, I found the solution. And so this volume by displacement method, because that's what Archimedes used in this story, is often called the Archimedes principle. The density of the zinc object is calculated from its mass and its volume. So on the previous slide, that volume displacement method told us that the volume of the zinc object was 9.5 centimeters cubed. You can weigh it on an analytical balance to determine the mass, 68.60 grams, and you get 68.60 grams divided by 9.5 centimeters cubed gives you the density. Here we are rounding to 2 significant figures. Even though you can get 4 significant figures from the analytical balance, because of the graduated cylinder that you used, you could only estimate out to 2 significant figures. Thus, your answer may only have 2 significant figures. And of course, the units for density are always grams per cubic centimeter or grams per milliliter. Here's a learning check. What is the density in grams per cubic centimeter of a 48-gram sample of a metal if the level of water in a graduated cylinder rises from 25.0 milliliters to 33.0 milliliters after the metal is added? Here you will have to use the principles of the volume displacement method in order to determine the volume of the metal. So pause this video while you get your answer. Now let's go through the math together. Once you drop the object into water in a graduated cylinder, the level rises from 25 milliliters to 33 milliliters. The difference between 25 and 33 is 8 milliliters. This tells you that the volume of the object is 8 milliliters. The density of the object is the mass, 48.0, divided by the volume, 8.0. And that comes from this equation here. Density equals mass divided by volume. Because the volume of the metal is 8.0 milliliters, and we know this from the volume displacement method, we can do 48.0 grams, the mass, divided by 8.0 milliliters, the volume, and that works out to 6.0 grams per milliliter. Again, you can only express your answer as two significant figures because the volume was only in two significant figures, even though the mass was in three significant figures. Also, remember that this can be expressed as 6.0 grams per milliliter or 6.0 grams per cubic centimeter. They are the same thing. Let's go back to thinking about the picture that we looked at the very beginning of this video. Water has a density of 1.00 grams per mil. Ice floats in water because the density of ice is less than the density of water. For example, ice is only 0.92 grams per milliliter, so this is why ice floats. Aluminum sinks because its density is greater than the density of water. Its density is 2.70 grams per milliliter. And so characteristic substances have specific densities associated with them. Water is always going to be 1.00 grams per milliliter. Aluminum will always be 2.70 grams per milliliter. Lead will always be 11.3 grams per milliliter. And so these are actually values that you can look up in a reference table. Which diagram correctly represents the liquid layers in the cylinder? Caro syrup, which is abbreviated by a K with 1.4 grams per milliliter in density. Vegetable oil, represented by a V with 0.91 grams per milliliter. And water, represented with a W with a density of 1.0 grams per milliliter. Choose which of these scenarios is most likely based on the densities. Pause this video while you determine your answer. Here is the correct answer. Remember that things with a heavier density than water, like the Caro syrup, will sink. Things with a lesser density than water, like the vegetable oil, will float on top. Remember in the previous video, we learned about problem solving. Density can actually be written as an equality and used to solve problems. For example, a substance with a density of 3.8 grams per milliliter, an equality can be written showing that 3.8 grams of that substance is equal to 1 milliliter of that substance. And from equalities, we know that we can write two different conversion factors. So here, 3.8 grams per milliliter and 1 milliliter per 3.8 grams. Here is a learning check where you will have to use density as a conversion factor. The density of octane, a component of gasoline, is 0.702 grams per milliliter. What is the mass in kilograms of 875 milliliters of octane? Remember here that you will have to convert from grams to kilograms, and you can use the density as a conversion factor to move from milliliters to mass. So pause this video while you determine your answer. So first, let's write down the equalities that we will be using. Density, 0.702 grams of octane equals 1 milliliter of octane, and 1 kilogram equals 1,000 grams. And here we set up the problem. We were given 875 milliliters of octane. That was our given unit. We can use the density conversion factor to move from milliliters to grams. Note how we are setting up this problem so that the milliliters cancel. We can then use the conversion factor with grams and kilograms so that the grams cancel, leaving us with an answer in kilograms, which is what was requested by the problem. Remember here that we have three significant figures in 875, three significant figures in 0.702, but here this is an exact definition because grams and kilograms are both within the metric system. And so this conversion factor will not affect the number of significant figures in the answer, which is going to be 3 because that's how many each of these other numbers has. Now let's talk briefly about specific gravity. Specific gravity is a relationship between the density of a substance and the density of water. It is calculated by dividing the density of a sample by the density of water, which is always 1.00 grams per milliliter at 4 degrees Celsius. Specific gravity is a unitless quantity. This is because the density units of the sample are canceled by the density units of water, leaving specific gravity to be a number without units. A substance with a specific gravity of 1.00 has the same numerical value as the density of water. So specific gravity is simply the density of the sample divided by the density of water. And because the density of water is always 1, the density of a sample is the same number as the specific gravity. So, for example, with aluminum having a density of 2.70 grams per milliliter, aluminum would have a specific gravity of 2.7. So the specific gravity is the same number as the density, simply without the unit.